Today we're going to talk about inverse functions. For every one-to-one function, we can interchange the domain and the range and find a new function called the inverse. Remember that a one-to-one function passes both the vertical and the horizontal line test. So the first thing we're going to talk about is notation. How do we write what is the inverse? So if we're given the function, f of x, then the inverse of that function is written like this. F to the negative 1 power of x, f inverse x. Graphically, take the line y equals x. The inverse of a function is a reflection over that line. So if this is our function, f of x, the inverse, you're going to take it, reflect it over that line. Okay, should be equal distance. That's our inverse function. So graphically, it's a reflection over the line y equals x. So when we talk about that reflection, if it was just a set of points, let's say this point was 1, 3. Then the reflection would switch the x and y and be 3, 1. So we can reflect the entire graph, but it also means switching the x and y values or switching the domain and the range. So function notation for inverses, f to the negative 1 of x, graphically reflects over the line y equals x, switch the point, 1, 3 becomes 3, 1. Next page. How do we find the inverse of an equation? So if we're given a function such as y equals 3x plus 2, the first step is to switch the x and the y. Now if you were given f of x here, you have to remember that f of x is y. Okay, so the first thing that we do is switch x and y. X equals 3y plus 2. Now we're just going to solve for y. So we need to subtract the 2. So we get x minus 2 equals 3y. Then divide by 3. So we get x over 3 minus 2/3 equals y. And then, to show that this y was the inverse of this original function, we replace the y with our inverse function notation. So f negative 1 of x equals 1/3 x minus 2/3. And that's your answer. Nothing difficult, just got to remember the steps. Switching the x and the y, solving for the y, and then most of the time we use this notation to show it's the inverse of the original function. Next page. Try this one. Pause the video and see if you can do it. Switch the x and the y, solve for y, and then just write it with inverse function notation. So again, we have to remember that g of x is y. So we'll switch the x and the y. This is the cube root, so to get rid of the cube root, we're going to cube both sides. So we'll cube this side, and we'll cube this side. So the cube root of something cubed is just the something. Remember, we're solving for y, so add 1 and divide by 2. And then remember, we just want to use the inverse function notation. Try the next one. Again, pause, try it on your own, and then check. So remember, f of x is y, so we'll change that to x. Switch your x and y, solve for y. So now we have to square both sides to get rid of the square root. X squared equals y minus 4. So we squared both sides. And then just add 4. Again, use your notation. Okay, next one. Again, pause, try it on your own, and then watch my explanation. Switch your x and the y. We're solving for y, so the first thing we're going to do is move the 1 to the other side, so x plus 1 equals y plus 2 quantity squared. Take the square root. Remember, when we take the square root, we use both the positive and negative, and then subtract the 2. Inverse function notation. Except there's one problem here. If we look at the graph of this function, it's a parabola. Once we take the inverse, it's a parabola tipped on its side. This is not a function. It does not pass the vertical line test. If you go back and look at the first page, we said for every one-to-one function, every one-to-one function. Parabola is not one-to-one. So what we just have to do in this case is we have to limit our domain. If we delimit the domain of the original function, then when we take the inverse, it exists. So basically when we take a parabola, we just take 1/2 of it, because then it's one-to-one. So this cannot be an inverse because it's not a function. However, each part is. So if we limit the domain from the first part and make it x greater than or equal to 0, then really what we're saying is that the inverse is just the top part. So instead of having the minus, we take that away. It could be one, it could be the other. We can just have the top, or we could have the bottom. At the moment, don't be overly concerned about the one-to-one part and restricting the domain. What's most important at this part is understanding how to find the inverse, switching the x and the y, and then solving for y. In class, we'll talk more about how we limit the domain, when that will come up as a question, and what we need to do with it. But I just wanted to show you that it can happen. So here our final answer is -2 plus the square root of x plus 1, because we can't have both. Make sure as you're watching the video that you've written down any questions that you have